Ah, sí, 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 porque no va a durar. Ya lleva un rato conectado, así que tú no lo necesitas, ¿no?
Un poco por si acaso para usar. Si yo, para tenerlo por si acaso. Que vaya pegado este.
I think it's we have plug.
I think debe.
No, no, déjalo en el suelo. Lo dejo.
Oh, oh.
Vale. Sí, pero necesito. No, pero.
Debe así ya.
Pero igual no llega. No, ponlo aquí, Miquel. Que va a ser mejor, sí. Pero por ahí y así yo me libero de. No. Hay uno, ¿eh?
So, good evening, everyone, and thank you for coming. This is one of a series of public lectures that we do through the Malta Group of Professional Engineering Institutions that represent the professional engineering institutions in UK, the IIT, IMechE, and ICE. And today we have a guest speaker from Spain, Ildefonso, from the Promise project, which is also coordinated by the Foundation for Innovation and Research Malta. So basically, CENER is you will describe more about CENER, but I've visited a number of times and I've been very close following and also partners in at least two projects now.
Yeah. I hope the third one.
Looking forward for more. So basically, I leave it up to Ildefonso to introduce himself, CENER, and a bit Promise project, I guess, as well. And yeah, and then so it will take about 45 minutes, and then questions and answers.
Okay. Thank you for your introduction, Brian. Hi, everyone. My name is Ildefonso Muñoz. I belong to CENER. And welcome, everyone, to this presentation inside the Promise project entitled Design, Operation, and Maintenance of the Photovoltaic Installation, a General Approach and Points of Interest for Malta. First of all, I would like to briefly introduce CENER. CENER is the National Renewable Energy Center of Spain. It develops applied research in renewable energies and provides technological support and companies, organizations, and energy institutions, as well as public and private, in 5 technical areas: wind energy, solar energy, biomass, energy transition in cities and grid integration on renewable energy. Focusing in the solar energy department, our activities are diversified just around the world with more than 2,000 commercial projects and more than 1,000 clients just around the world. So Tener is a main actor in the research and the development of the new solutions in the solar energy, for the energy transition, and supporting the whole industrial chains and institutions worldwide. And specifically, with solar photovoltaic energy area, we can provide services and competencies and knowledge in the complete value chains of the solar photovoltaic technology, from the solar cells to the PV plant. Our emblematic or flagship activities in PV components and installation, among other ones, is the mechanical load bench, our activities on site and testing in PV plants, the aerial electroluminescence on site, our soiling test bench is our own design for this test, the experimental PV plant, and of course the PV component lab for the accredited laboratories regarding to the PV modules and solar tracker. As an introduction, there is no doubt that solar energy has grown and expanded globally in the recent years in a dramatic way. The abundance of the solar resource compared with the other energies, and the decreasing of cost of the equipment in the photovoltaic solar energy have allowed for a large growth of these systems, and consequently the growth of the associated industry. In this fact, solar is becoming not a renewable energy, but the energy. In the case of Europe, the number of PV installations are increasing in all the European countries of the European Union. This is like that, and of course, in Malta. But before starting, the generation of electricity from photovoltaic solar energy requires not only the knowledge of the photovoltaic, specifically photovoltaic knowledge, but we need the knowledge in different technologies, equipment, and the know-how. So main questions that should be answered in the development of the PV plants are: what is the most suitable type of photovoltaic system for my location? This question is regarding to the solar resource. What is the optimal design depending on the objective to be achieved with the photovoltaic plant? So regarding with the selected equipment, the configuration, and the engineering of the PV plant. What are the criteria for the quality and operation of these plants? This is regarding for the operating and maintenance tasks, the contracts and warranties. And finally, all these considerations are applicable for Malta. And spoiler, yes, of course. Well, a general classification of PV plants, focusing the question. The most typical classification of PV plants will be divided in grid connected, with and without self-consumption, the standalone, with DC loads, with AC loads, and both of them, and the smart grid or distributed generation that combines or it has the capability to connect and disconnect from the utility grid. The classifications of PV plants according to the location could be the classification of ground level, terrestrial or floating. The building adapted in photovoltaic, for example, rooftop applications, and building integrated. That in this situation, the photovoltaic installations is a constructive part of the building. It's an architectonic part of the building. So these are examples of different types of PV plants at ground level, floating, BIPV on rooftop, and in this case is building integrated. That because the part of the PV plants is part of the build, an architectonic element. And other classification of PV plants, depending on the type of tracking, could be fixed PV plants, one with one-axis solar tracker and two-axis solar tracker. Depending on the use of terrain, the single use or dual use, like hybrid PV installations, agrivoltaics, etc. And depend on the type of the module. It will be monofacial, bifacial, or the concentrated. Let's look at have a look at the electrical protections, both in DC and AC. The sensor plus monitoring and SCADA systems to monitoring the PV plant. And additional components, that's batteries, pumping, or cleaning systems. Regarding to PV modules, is the main component from the point of view that it's the element that generates the power. The PV module is composed by the solar cells. The PV module is based on the union, the mechanical union of the solar cell that generates the electricity. Currently, the photovoltaic say that is prevailing. The technology prevailing is the monocrystalline silicon. The way to generate the electricity of PV plants is like the typical IV curve. So the power of the modules depends on obviously the level of irradiance, but depends on the level of the temperature. These are the two main parameters of this generation. So this is the typical curve, the generation of the PV modules. So the association of different PV elements is the sum of these IV curves, depending on the series connections or parallel connections. In this case, if you have this graphic, we can see the parallel connection as a sum of current at the same voltage, and the series connection is the sum of voltages at the same current. PV modules contains the protecting elements like bypass diodes in order to avoid situations that provokes modification of the IV curve like dust, soiling, or shavings. This provokes deformations or modification of the IV curve. That is a problem that we see later. Regarding the PV inverters, PV inverters is the brain of the PV installation. As we say, the PV module is the generating element of the PV installation. PV brains controls this generation and the injection to the grid. The main functionalities of the PV inverter is the control of the working point of the PV generator through the maximum power point tracking system, the conversion of the DC energy into AC energy with certain wave quality requirements, the synchronization with the grid and energy injection. Normally, PV inverters have a lot of system integrated, like protection system, PV insulated monitoring, anti-islanding, and voltage dips, safety elements and auxiliary systems, and other functions that currently is under development. The selection of the PV inverters depends on the operating range of that PV inverter. And of course, this operating range must be in accordance with the electrical configuration of the PV generator. So we can find out a lot of types of PV inverters, depending on the power, the operating range, and so on. We can distinguish between central inverters, the string inverters, and multi-string inverters, and the AC modules. Central inverters group a lot of string inverters in only one MPPT. The string inverters can work with any string configuration, and the AC modules is the inverters placed on each PV modules. The solar trackers is another main component of the PV plants. It's a mechanical element to modify the orientation of the plane of irradiance of the plane of array. So it generates an increasing of the collective radiation, but increasing the cost of PV plants. The main configurations of the solar trackers is one and two axis, and polar axis is one axis, and azimuthal axis and horizontal. And this graphic shows the radiation in the plane of array, depending on the solar tracker. In blue, this is the horizontal, the radiation collected in a horizontal plane. The orange is an fixed but an optimal oriented with no tracking. Green curve is corresponds to a single axis, horizontal single axis, and the red one is corresponding to dual axis. Obviously, it seems that the best option is the dual axis, but not in all the case, because dual axis have a huge cost. So the gain that generates for this tracker maybe is not enough to apply for this cost. So it depends of the percentage of the gain we can observe in this table, depending on the locations. So the gain compared with the plane of the optimal tilt of the plane, gains is not so far from the point of view of the horizontal gain. So the selection of the solar tracker must be made with very careful. This is a yeah, well, this is a design criteria. We talk about this point of view because we can select the the ratio of the separation of these our solar trackers depending on other considerations, because the land occupation, it will be a key point, because probably in some occasions the cost of the land will be a high cost. So we need, for example, for example, for example. So let's talk about this point later. This is in asking way of what is the steps in a plan project. There is a lot of steps and a lot of stakeholders that is necessary to management in the PV project. The initial, like starting investors, the project developing, the financing, design and engineering of the PV plants, the purchase and procurement, building and commissioning, the operation and maintenance management, and monitoring and sales. All must be integrated in the PV project management and quality assurance. In a fast way, chronologically, we can identify this stage in the PV selection. From the site identification in the stage 1, selecting what is what object is, where is our location to place the PV plant, from a pre-feasibility study and preliminary PV project, financing and cost, and finally the PV project, the design and the construction. Starting the operation with the commissioning and the normal operating with the stage 8, operating and maintenance, and finally the dismantling of the PV plant after its lifetime, and the lifetime. So, first one to take into account is what is our location. What is our solar resource in the selected location? It depends on the longitude, latitude, our position on Earth, with different solar sun paths and different sun hours, and the component of the radiation in our location. Depending on the location, considering sun path, number of sun hours, and component of radiation, we select or we take any decision, one or other. With the solar resource, it's necessary to make an energy estimation from the database, necessary data with the radiation and temperature, and other recommended data like the diffuse, wind, and other data. We generate a typical meteorological year, and we must select our technical specification of the PV plants in order to make a simulation of the energy production. This is in the first stage of the plant. But the design of the plant is not always the same. We can put on the table different design strategies. For example, a lower levelized cost of energy, a higher return of investment, or lower initial investment, a higher ground coverage ratio. In this case, for example, if the cost of the land, the cost of land is very high. We need to optimize this point very close, or maybe we have experimental installations or emblematic projects that is necessary to put in to work with no specific requirements. So people and design strategies depend on fixed costs, not related with the energy production, the location, the financing conditions, obviously, and probably the technical or legal limitations. Designing of the PV plant is basically the design of the way to minimize or avoid loss factors, because it exists a lot of loss factors in the designing and the operating of the PV plant. Basically, we can define 3 types of loss factors: the radiation loss factors, the DC side loss factors, and the AC side loss factors. It's very typical, this kind of diagram, starting with the radiation in the horizontal plane, in this case with a gain of a solar tracker, different loss factors. Different loss factors in radiation, the conversion of radiation in electricity, and the different losses in both DC and AC energy. And finally, this is the value of the energy produced by year. First one, the radiation loss factors regarding with the incident angle is the radiation, the incident of the radiation that incides in the surface of the PV module is not taking advantage of us in some degrees. So there are factors of reflections that is allowed. Obviously, the soiling is one of the main parameters of radiation loss factors, and is depending of location, we can found different degrees or different estimations of the soiling. And obviously, the shading, that could be a near shading, or mutual shading, or far shading related with the horizontal line. Here we can see some examples. For example, in a fixed PV installation, the sun move is the affection of the shading. For example, with solar trackers, this is a very interesting animation, because it's the same installation with a strategy with backtracking and without backtracking. Backtracking is the functionality of the solar trackers that permits not tracking at the beginning and the end of the day, in order to avoid the mutual shadings in this part of the day. So in this case, the following is complete, but it's generating shadings at the end of the day. In this case, the tracking is stopped, and in this way, there is not a tracking, but there is not a shading too. This is a real case of the installation that we are working at Cener. In this case, it's a BIPV installation, and this is the analysis for the future installation of different PV installation in different orientations, in rooftop and in facade. And finally, sorry. This is another case, specifically in one house. From the point of view of DC side loss factors, PV modules has a declared PV nominal PV power, but only in specific conditions. So the differences of this condition generates different losses regarding to the temperature and the irradiance. So especially with the temperature loss factors, this is an important point from the studying, because it's one of the main loss factors. The behavior of the photovoltaic modules is not the same that in the STC conditions. That is declare its power. So we have taken into account. The mismatch loss factor is one of the main loss factors. This is due to the fact that all the PV modules are not the same. Instead of we have the same PV module, the same brand, the same power, it's not exactly the same. So differences generates these losses. Normally, all the PV modules have a tolerance about the power that they can offer. In this case, I don't know what is the amount of the PV modules studied, but in this case is the IV curve representing with all PV modules with the minimum tolerance, and this is the curve with the maximum tolerance. This is the expected IV curve with average tolerance, but in the real case, is this one. Because all the differences generates a loss factor from this point to this point. And one of the DC loss factors is the fact that the PV plant we can see as an electric circuit. So obviously it's an ohmic loss factor depending of the equivalent resistance of all these elements. Finally, the DC loss factor including the operation of the PV inverter. This is regarding with the MPPT system that is capable to find the optimum value of the IV curve, especially in situations with shading, with dust. To be honest, almost all the PV inverters have a very, very good behavior in this point So practically, this is a negligible loss factor. Negligible, sorry. The AC side loss factors involves, obviously, the PV inverter too. So the conversion from DC to AC is not perfect, obviously, and this is a efficiency that depends of the level of the output power. Depends of the voltage. It's very usual this type of curves of the maps of efficiency. And in the AC side, we're taking into account the losses of the low voltage and medium voltage transformer and the transmission line. In case of the transformation center is in a distance subversion, the transmission line losses could be very important. So all these factors give us estimation of the energy production, but it's a probability. It's not a fixed value because most of these factors is not determined precisely because it depends of this generation. The main case is the solar resource that is could be variable along the years. So we obtain a probability curve of the production of our installations. If we select the worst conditions, we obtain a expected value, for example, in the percentile 99. Or if you select the average condition, the P15, we obtain a expected value, a different expected value. We have to take into account this one and the long-term estimation, but the production of our PV plants is depending of the losses, the degradation losses of our installation regarding to the PV modules. So the metrics of the main metrics of the installation is just I'm talking just of this one and this one, the performance ratio that we obtain this value, an idea of how is the behavior of our PV plant compared with the same PV plant with no losses. This is a value. This is the idea of this value, and the availability is a parameter that is the percentage that the PV plant is working. It is not yes, it's working, because in some cases when the plant is not working because there is some crash, some problems, this gives an idea our maintenance. How is our maintenance of the plant? The operation models of the PV installation is regarding with the electricity generation of photovoltaic power plants is regarding with the electronic generation. Compared with the conventional generation that is synchronous motors, synchronous generation, the voltage and the current is integrated, is not separately. But it is possible to separate in an easy way the voltage and the current in the PV inverter. So it's possible to make extra functionalities like active power relation, the regulation of the power through frequency, the reactive power control, supporting events of static voltage and dynamic voltage supports, like low voltage right-through, voltage dips, and so on, and the compensation of the reactive energy. This is possible. It's extra functionalities compared with the conventional generation systems. The maintenance and the detection of defects. We can talk about the maintenance strategy, about the corrective, the urgent case, the predictive, and the preventive maintenance. But this is a conventional strategy of maintenance in every installation, in a conventional installation, in everywhere. But this classic structure of maintenance strategies is not completely, not fully applicable in PV for PV plants, because in PV plants occurs is the presence of degradations. Degradations phenomena in PV modules. So there is not fail, no fail conditions in PV modules, but it could be possible degradation phenomena. So the operational maintenance in PV plants needs a new approach. It's necessary a measurement, because it's necessary the detection of defects and events of failures to know what is the status of the PV plant. It's necessary measurement techniques. It's necessary the analysis of these measurements, because there are events of failure that implies not only a fail, no fail condition, but events of degradation could be severe, not severe, or with no effects. And all this necessary to have a decision making. The maintenance actions affect availability, the parameter that we will talk, and the production. So it's necessary to extend the concept of maintenance, not preventive, predictive, corrective. So we extend the concept of maintenance to adjusted maintenance. It's necessary to know what is the moment to make a reparation, to apply a correction, etc. The objective is always the same: maximize the production and availability of the PV plant, increase the reliability, and minimize maintenance cost. This happens only in PV modules. PV modules are generally considered the most reliable components of PV plants. But they are involved in a short number of even of failures in comparison with other PV systems, typically not appearing in both. But PV modules critically compromise the viability of the PV projects, because the cost of the modules is almost 50% of the complete PV project. The expected lifetime of PV modules is more or less 30 years, but the effects of degradation could lead a situation of underperformance. And the detection of the repair or replacement of a large number of PV modules can be very costly if adequate warranties are not provided for in purchase or sale contracts. It's more easy to claim warranties than to substitute or change a huge amount of PV modules. So it's very important, this point. So there's a lot of measurement techniques. We can find all these techniques sort of like the complexity and cost of these techniques, and this is a sort of kind of defects that we can find in a PV installation. So depending on the size of the requirements of our PV installation, we must select the suitable technique to measure of the PV modules of the PV plant. In CENER, we are working in the electroluminescent technique. This is the most powerful technique, but it's the most complex technique, and it's not suitable for all the PV projects because it implies a high cost that it would be not necessary in determining PV plants. Electroluminescence can detect a lot of problems. These are some of examples of degradation or failure problems. The presence of different type of cracks, potential induced degradation patterns, in this case, corrosion of metallization, brick and fringes, discontinuous tabbing, so short-circuited bypass diode. It's a very powerful technique. And this is an example of the defects that occur or can occur in a PV module that is detecting by the electroluminescence. Yes, it's one of us stepping over a PV module. Generating of cracks occurs inside the module. It seems that there is no an extra effect because the module has a certain flexibility and recover the position, and there is no loss of factor. But the crack exists and evolve in a degradation ways along the time. So this module probably its lifetime is reduced, and the loss power is reduced in 5-10 years. It's not 30 years lifetime. This model, but it's not detected. It's not detected now in the rest of the techniques. Could be not detected. When the PV installation is a very a huge amount of PV modules, it's necessary to implement another techniques for electroluminescence, and the use of drones is necessary in order to acquire with adequate speed all this data. And this is an example of our drone in a real installation. Mechanical strength affects the same. Yeah, in this case, it's affected in the same way. So, this is the resolution of these flights, and this is a very interesting video, because there is a part of a commissioning in a commissioning stage. So this, sorry, we can take it new. These modules, all these modules, are completely new, both of them, and it's the same brand and the same power, but these modules belongs to the different batch that this one. This is made by the factory placed in, I don't know, China and Malaysia, and it's declared the same power the same characteristics, but after the installation, presents different conditions. Oh, after 6 months. Okay. Yeah. Okay. So it's important to this technique is very important, but is capable to detect failures not with pass times, in the moment of the installation, depending of the manufacturer, the factory where the PV modules are made, or events of the bad handling installation, and so on. So it's very powerful. And this is a real case that we have analyzed. In the case of the operating and maintenance regarding to the PV inverters, there is a important research line in THENER, and we can take about the effects of the temperature in PV inverters efficiency. It's a important point because there is a lack of information about the behavior of the PV inverters, the efficiency of the PV inverters with the temperature, with the behavior of the temperature. In this case, this is a measurement along the day. We can select, we can identify, the behavior at the morning and in the evening. The heating of the electrical elements reduce the efficiency of the PV modules. In fact, there is some manufacturers that is starting to indicate the ratio or the declared power regarding with the temperature. In this case, it selected the nominal power at 30 degrees and 50 degrees. And in this graphic, we can see some other events like the limitations of the injector current regarding to unknown events. This inverter should inject following the curve of the radiation, but in this case, it's limited. This is a malfunction of the PV inverter. Solar trackers. The main research lines of the operation and maintenance is the detection and unexpected malfunction of solar tracker based on data analysis of event or failure. In this case, this is the curve of the radiation in a horizontal plane, and we expect that the curve in a horizontal single axis presents this curve, but in this case appears this dips that is placing the tracker in the horizontal position. This is another malfunction. And in some cases, there are a bad design of the PV of the solar tracker. So sorry. Like this case. I hope so. It's too slow, but finally it happens. This a poor design of the solar tracker because uh, the wind is not huge. It's not so huge to provoke this effect. This the calculation of these supporting structures is incorrect, and the design of the protection and the detecting the value of the limitation of the wind is not properly designed. So the consequences are the destruction of the solar tracker after. I think this in the. It's too slow. This is the deformation of the solar tracker. The rest of the elements in the PV plants, the supporting structure could lead a destruction of the PV plant. We can found a poor design of foundation, the ground fixings, as you can see, is almost with no support, with no point of support, and the foundations is not properly designed. The rain is completely removed of the supporting land. There could be an incorrect identification in generation element, wiring, and control cabinet, and the monitoring system management could be not properly identified. So the data storage, the alarm, and the analysis is not made, literally. In this case, for example, this is a monitoring system added after the installation of the PV plant, but there is no any kind of maintenance. There is no any kind of managing of this data, and the protection system, in addition, are not properly working because the fuse was not checked, and half in bad condition are broken. So it's important at this point. Okay. We'll talk about all the specification, all the problematic, all the points to consider to design the PV, our PV plant. Let's talk about the points of difference in Malta. The specific conditions in Malta is the large country in the European Union by population density and the 8th in the world, with the coordinates just in the middle of the Mediterranean, and the climate is inside the definition of the Copenhagen climate classification, with a high levels of soiling. And this is the framework of our location. It's one of the European countries with highest level of irradiation, and on average, 17% of this irradiation is direct irradiation, and the 30% is diffuse, with an average yearly sound of global irradiation range between 1,800 and 2,000 kilowatts hour per square meter in horizontal plane, and up to 2,150 in optical plane. So, good conditions, really good condition. What is what could be the most important impacts for PV solar energy in Malta? Okay, from my point of view, the grid operation, the photovoltaic installation can increase the promotion of the cell consumption. The best energy generation is what this energy is consumed in the same place. There is no losses, there is no extra effects. Is the most efficient way to generate. Reduce the energy dependence. So it's solar energy is energy resource property of Maltese population, Maltese island. Increase the reliability and stability of the power system. So we can increase the reliability because the sun affects to the production. We can stabilize the demand, the offer and demand of the energy. Obviously, the cost reduction in power generation. It's a free resource, free energy resource. The low environmental impact with no emission, especially in rooftop. There is no land occupation. There is no affection to the terrain. So it's a very, very low environmental impact. The flexibility and adaptability to different size allocations, obviously. And the use of local resource, applying dual use of land. The possibility of the PV installation is combined with another activities, like the agrivoltaic, like the primary sector activities. It's compatible with the dual use of the terrain, and it's very important in island conditions. From our point of view, what is the proposed suitable application for PV plants in Malta? The rooftop installation, of course, is a more suitable PV installation for Malta. I think it's a fact. The floating PV plants could be the best approach to think in a large utility scale PV installation, because there is no surface enough in terrain in Malta. Sorry. The agrivoltaic as a new strategy to share land, to use and protect crops from excessive irradiation levels. From the point of view of the agrivoltaic, not only is the generation of electricity, but the protection of crops and the possibility to incorporate new crops, because the local conditions of the crops is modified almost under your selection. And the creation of energy communities as the application of new paradigm, the prosumers. So the local electricity consumer and producer at the same person, the same entity. So it's the most efficient way to generate and consume electricity. And finally, the summary of this presentation. The solar energy is the most abundant and readily available resource anywhere in the world. And the photovoltaic solar energy is suitable for virtually all electricity generation purpose, especially because of its lower cost. The photovoltaic systems come in a wide variety of types in terms of size, configurations, and equipment. The previous knowledge of the radiation condition of the location is necessary to adapt the type of photovoltaic installation to the specific needs of the site. In a large photovoltaic projects, the phase of operation, contracts, and guarantees among the stakeholders inside the PV project must be clearly defined. The design, construction, operation, and maintenance of a photovoltaic plant require a thorough knowledge of the different technical aspects, including the installed equipment. In PV plants, the concept of maintenance includes failure detection and evolution. It's a key point in the PV plants. And of course, solar photovoltaic is perfectly suited for Malta's need, presenting new opportunities in its use and applications. And finally, I would like to thank to all our colleagues of Promise Project and the staff that we have great support in our state and we help, especially Steve, Greg, Asteja, and Brian. Thank you. And it's a small joke because this is one of the streets very close to our headquarters in Pamplona, and this is the picture from our hotel in Malta. So I would like to say greetings from La Valletta Street to Valletta, not La Valletta, to Valletta City. So thank you very much. I think.
I think we will place this. It is already online.
Is it already
Yes,
online?
because it's live stream, so it will remain there.
Oh, that's good.
and
But it's no problem. If you want it, you can in my car.
But thank you anyway.
Okay, so then
By any
better
chance.
with the mic.
Really?
Yes. But you don't need to hold it. So.
Okay. Am I being heard?
Yes.
What I'm most interested in is for a relatively small house, for a small family. What about off-grid systems that just use direct current? I mean, I would be willing to buy this washing machine and this fridge, sort of simple living, and gain independence from a Malta and arms limited. What can you tell me about that situation?
Yeah. Okay. First time we are focusing on the huge plants, but it's not the case of the small plants. But it's suitable. First of all, we make sure that we have the necessary surface to have the required power, because you can think what is your needs. I need to cover all my requirements, all my energy solution, or only one part. So this is the first decision in order to think what is the design of the PV plants. We need an extra PV panels, or only one part of these panels. And what is the support of the installation? Because in certain houses, you can acquire the independence of the grid, take off the connection of the grid, but you need a supporting energy system, because sun is only by day. The night you need the consumption.
Yeah, I can understand that I will need batteries for the night.
But
I
you
would
need
also like to do away with inverter systems, because those are the ones that fail in a PV system. What fails first? It's always the inverters. No, after about 10, 12 years at most, they fail, and you have to replace them. The actual PV panels can last 3, 30, 50 years. At least in the Alps, they have lasted 50, 60 years.
Yeah.
No?
You're talking about the lifetime of the PV system, the domestic PV system. It's about. Sorry, I don't understand the way
The actual PV panels.
Yeah.
Actual photovoltaic panels. It has been proved, because they have been tried and tested in the Alps. Okay, it's a very clean environment and rather cold, not hot. They have lasted for 50, 60 years. They were first installed in the 1960s. No one there, as far as I know, they're still up and running. So the actual PV system the photovoltaic panel can last at least 50, 60 years. But what we have been doing in Malta these past 30 years, most of us are sort of obliged to connect them to the distribution system of Malta and to sell any extra to them only. And that involves the inverter and whatnot. And that is where things usually fail with the inverter. Isn't that true? So if at least I'm interested in having a DC system, I can buy a DC washing machine, a DC fridge, and DC things. They're all available, you know. And for heating, I would still prefer a solar water heater rather than an electric element. Now, perhaps in Spain, that's already been done because Spain is much larger, and I'm sure there will be quite a few areas where what I'm talking about is feasible and perhaps even necessary. That's what I would like more information about. What has happened in Spain with regard to standalone houses, villas, whatever.
To be honest, it's not it's not the case in Spain because Spain in the probably the rural houses or something like that because the main case in Spain is a the large installation. So we have more knowledge about the small systems because all the small systems are supported by the connected. It's very short number of installation of the base of the
So the degradation of the PV panels in Malta is much higher, given that they are semiconductors basically. And from my personal experience, I haven't had any failures from inverters that I use in small houses. So I don't have experience that inverters fail before the PV panels. It's usually actually the contrary. You have a single panel which is failing, and it starts to degrade the whole system if you don't take care of that particular panel. So from my experience, it's not the inverter that goes first, it's one of the PV panels.
Thank God, ours hasn't failed yet, thank God, but it's been going on for a long time. But people think that
I think it depends. It depends where the inverters are installed. If they're in direct sun or not. That really affects their performance for sure. But other than that, I haven't had that experience. That's what I can say.
In our case, I think PV inverters is planned the substitution because it's an electronic devices. That the lifetime of PV panel is expected that is very short than the PV module. But there is a lot of types of warranties to substitute or to increase the power. But the reduction of the PV module in the production by degradation is in some cases is not recoverable. You already installed this PV module, and in most cases there is not substitution or repowering after the lifetime of the PV module is completed. I don't know if this is the case in. You are talking about the Malta case, the increases of the PV or the behavior of the PV modules. It could be a shorter lifetime in this case, comparing with.
Basically, you have to replace one panel so that you restore the performance of the whole array. Usually not the whole array goes, but just one single panel or one single module even in a panel, and you have to just replace one of the panels.
Yeah.
To restore the performance, and typically you don't find the same model, the same current and voltage performance, so you have to basically replace it all.
Yeah, this is a knowledge. In fact, this is a knowledge to be considered in the designing of the PV plant in order to plan all the necessities and the behavior of this installation.
And based on your experience, which obviously it's different from our case in Malta, why do inverters fail? Is there a common problem? Is there something which is more common than the other things?
Yeah, basically, is the nature of the PV inverters is completely different of the modules. So it's based in an electronic devices that its lifetime is short than the PV module. So almost all the companies of PV inverters offers warranties to change, to substitute this equipment in a certain time. So obviously the increasing of the temperature in the operation of the PV inverters decrease this time. So it's very important all the systems to ventilation, to the refreshing, because the forces of ventilation, because we saw cases where the filter is completely blocked and there is no ventilation, and it provokes a failure of the PV inverters. Not a destruction, but the demands a reparation or even a substitution, because the temperature of the operating temperature is a key factor of the PV inverter.
So we spoke about the design, setting up, maintenance, operations, and whatnot. From an end-of-life perspective, considering there's such a huge push for solar energy, is there a holistic plan, especially in the European Union and Spain being one of the larger countries, in order to recover, recycle all these PV panels? Because as we know, we're pushing, and there's only one company which got set up last June or July in France, which recycles components of the PVs.
Mm-hmm.
Is there a plan? We're going to end up with such a huge mass of PV panels, and they're not quite repairable. So you need to remove and replace after 20, 25, 30 years.
In my opinion, to be honest, I think there is no plan for this question. Just in this moment, when the first PV plants are reaching the end of their lifetimes, we start to think about the recyclability of all these components. But there is not even a complete plan, or no a specific plan, no a national plan, no a regional plan, anyone. But the first trying to work in this point it's happened just now. So I don't know what is what will be the next steps, because the amount of components of it is huge. It's not clear what is the plan to recovery, to recycle, or so on. I think it could be a great point to study for the European project, and think in policies, in European policies, just about that. But
they're clean until they're being used.
yeah.
At that point, then it's a huge problem because
Yeah.
they pick up a huge.
Yeah, it's true. It's completely true. But in my opinion, from my knowledge, I think there is no specific plan. There is no there's not a strategy, a common strategy. And just in this point on these dates, we are thinking about this point. So I hope that we think with enough time to solve all these.
There are different projects nowadays working on
The first in the first stage. I think it's in the first stage of these projects.
There are specific course for this topic, so I think it's one important thing that is going to work in the next years. And there are companies that are developing their own methodology in order to try to recycle. In this case, for example, the train is the easiest one. This is part to recycle, and also to try to spread the silicon from the
So
capsule.
there's only one company, which is Muñoz, our oversight, which has managed to commercially start breaking down components of plastic, you have the aluminum, you have copper, you have the plastic apparatus.
Yeah.
Manufacturers are starting to develop these procedures in order to offer this possibility of recyclability at the lifetime of the model.
Okay,
This is a very initial stage.
So I see it's a large company. So let's say you have a huge solar farm and you bought it from a supplier. 25 years have passed, and as is, those suppliers don't offer you to replace, for example, the whole solar.
I believe there is an association which is called PP Cycle. So if you're buying, for example, from these manufacturers that are part of that association, they guarantee somehow, but I don't know how, but they guarantee somehow that they can recover the PP panel from you. At the moment, they are basically probably stocking it up, to make enough volume for recyclability. But there is this type of association between PP manufacturers.
There is a specific case, for example, First Solar, that manufacture chemical dry modules. The main manufacturer is in the USA, and they recover the module because, in this case, because of
It's toxic.
the contaminants is
Very.
So they recover the module.
But in this case, we are talking about toxic elements and very, very contaminated elements. So
My question regarding the feasibility of the floating installations, because to make a floating installation, it's quite expensive to make the pontoons, and they have to be stable. They are moving because of the waves.
yeah,
That all the sense of it will be lost because we won't have any gear. So they have to be very large installations and quite costly to have them stable.
this topic is under development because there are the first installations in open water, not in the coast. I think it's in Singapore. Yeah, thank you. So this is a chance under study, of course, to create a large large PV plants in Malta, because obviously there is no land enough in the side.
The platform. There are two platforms, one by university and one by MCAST. But it's just a small platform. Yeah, in a very focus. So it's a very interesting discussion, I think. Yeah. Maybe we can continue later on, not with live streaming. Yeah. I think thank you very much, Ildefonso, for your contributions to this public lecture. I think you made us really discuss this topic very well and attracted even some more people from last week, I guess, as well. Promise project still goes on till end of September 2025. And there will be another public lecture in February, I believe, and that will be on agri-photovoltaics. MGPI holds these public lecture and events on every next Thursdays, yeah, every other Thursday, yeah. Maybe Charles can invite you for the last session before Christmas, yeah.
First of all, I would like to thank you all. In view of the inclement weather, it's a very good reason for people to find an excuse not to attend. So I'm very pleased that we had a good audience for this presentation. As indicated, this is the third presentation in successive weeks that we had, and all of them are really interesting and of various subject matters that are definitely of big interest to all us who like technology and this sort of thing. So please, if you don't receive our circulars, just send us an email. You can look us up on our website, MGPEI. If you Google MGPEI, just make sure that when you write MGPEI, normally Google will give you MAGPI, MAGPEI. So make sure that it's only MGPEI Malta and it comes, and you will find the whole list of activities that we hold. It's always like Brian said, on a Thursday. It's always here, and the next one will be the last one for this year. It will be on the 14th of December, and because it's the one just before Christmas, we also have drinks after the presentation. So it's a good incentive for you to attend. Okay, thank you very much again for attending, and hopefully we'll see you again in some other activities that we are going to have in the next year. Thank you.
One last thing, because I see also some young generation as well, which is very important. In Promise is being built also a research platform related with PV monitoring. So later on there will be even data available on open access, so people can also research that. So please do follow also the Promise project, very simple, pvpromise.eu, and you'll see what goes on, yeah, during the years. Thank you very much.
Thank you.